Okay, so the very last thing we'll do for these week 1 slides, I'm going to give you here this sample calculation problem to work on. It's going to combine several of the things that we've talked about, unit analysis conversions, as well as significant figures. So this is a good problem to be able to work through. So let's read it, and I'll kind of describe my thought process as I'm going through this large problem. A material will float on the surface of a liquid if the material has a density less than that of the liquid. Okay, so back up and ask yourself, did you understand that sentence? A material will float on the surface of a liquid if the material has a density less than that of the liquid. Yes, okay. It's okay to back up and reread things if you have to. Given that the density of water is approximately 1.0 gram per milliliter, will a block of material having a volume of 1.2 times 10 to the 4th cubic inches and weighing 350 pounds float or sink when placed in a reservoir of water? It's a good question. My first impression is that it's going to sink. I mean, if I was just guessing, it's going to be a sinker for show, because it's like 350 pounds, right? That sounds like a lot, but we have to calculate it to find out. Okay, so how do we even start? Well, what we need to know is, will the density be less than or greater than 1.0 grams per milliliter? So that's going to be our test. And so that means we're going to need to take the mass divided by the volume of that object and get it into grams and milliliters so that we can compare. Okay? So let's do the mass first. The mass equals 350 pounds, and I want to convert that into a gram. Okay? And the volume is 1.2 times 10 to the 4th cubic inches, and I want to convert that into a milliliter. And then finally, I'm going to divide those two things out and see if it's greater than or less than 1 gram per milliliter. Okay? So if we go to our unit cheat sheet, let's back up for a sec. Where is it? Okay, here we go. So we know, okay, very good, look. 1 pound is 0.4536 kilograms, which is the same as 453.6. So 1 pound is 453.6 grams. Okay, so here's how we're going to use that number. Okay, so I'm going to start with the number, right? Remember, in our conversion process, start with the number you have. So I'm going to start with 350 pounds. And I know, and I'm going to do that process, right, where I go down and then up. So I'm going to put pounds here and grams here because I know I have a direct conversion. That cheat sheet told me 1 pound is 453.6 grams, and that's all I got to do. Pounds and pounds cancels, and I'm left with grams. And when I go and do that calculation, think about our sig figs. Look, I've got 1, 2, 3, 4 sig figs, but only here I have 2, right? Because I don't have that decimal point. So that 0 doesn't count because I don't have that decimal point. So that's only 2 sig figs. So when I do that calculation, my calculator gives me 1.59 times 10 to the 5th grams. And so I know, well, actually, I probably got more digits than that. So let me see, 350 times 453.6. So this is what I get. 158,760. Okay, so if I'm estimating, then I go 1, 2, 3, 4, 5. So 1.58760 times 10 to the 5th. I made it 1.59 with 3 sig figs, but you can see really with the 2 sig figs, it's only going to be 1.6 times 10 to the 5th grams. Okay. And now my volume, this is where this gets tricky. Okay, so I'm going to start with the number that I have. Start with what you have. 1.2 times 10 to the 4th inches cubed. And I'm going to do this process where I go down and up and down and up and down and up. So I know that I can put an inch here, and I need to get that to milliliters, And as a hint, remember, 1 milliliter is the same as 1 cubic centimeter. And the reason I'm pointing that as a hint, because check it out. On my cheat sheet that has the units, where is it? Oh, look at this. 1 inch equals exactly 2.54 centimeters. So when you see one of those things that says exactly, that means the significant figures don't count. So this is like not, these 3 sig figs here are not going to limit you. So 1 inch equals 2.54 centimeters. That's useful. Okay. And that's useful because I can say now, I know I can say in 1 inch, there's 2.54 centimeters, but I didn't get this to be cubed. So I got to cube the whole thing. Cube it. Okay? So not only, get out of there. So not only am I going to cube the units, but I'm also going to cube the number. Right? So when I go to do that calculation, that's going to be the same as saying 2.54 cubed centimeter cubed 1 cubed inches cubed. Okay? So that cancels out my cubic inches and my cubic inches. And then now I need to take 1.24 times 10 to the 4th times 2.54 cubed. Okay? And 2 significant digits from this number right here. Okay? And when I do that, I get, I'll just go ahead and do the estimate now. I get 2.0 times 10 to the 5th cubic centimeters, which I know is exactly the same 2.0 times 10 to the 5th milliliters. They're exactly the same. Okay. So now, finally, to calculate the density, Greek letter rho, it's going to be the mass, which was the 1.6 times 10 to the 5th grams, divided by the volume, 2.0 times 10 to the 5th milliliters. Okay, and when you plug that in your calculator, look, you're going to have 2 significant digits. I get 0.81 grams per milliliter. Uh-oh. I thought for sure this thing was going to sink. It's going to sink, remember, if it had a density greater than the 1.0 milliliters. But the density was 0.8, so that means it's definitely a floater. Okay, and that 350 pounds, right, that seems like deceiving, right? But its volume was significantly large enough that it would actually float on water. So maybe this thing was a boat, like a giant, heavy boat. Okay, so let's go to the learning goals, because that, for me, kills it for the slides. Okay, hey, how about that? Calculate the density of substance in any unit, given its mass and volume. We literally just did that, so I'll highlight that. That's awesome. Okay. Know the SI units discussed in class, how to enter, convert them, and how to apply scientific notation. We talked about that. Make sure that you feel good about that. Convert a quantity to another specified quantity through the process of dimensional analysis. So again, my process is to go down, up, down, up, down, up. Okay, we definitely did that. Apply significant figures in calculations and measurements. We talked about that. We talked about the difference between accuracy and precision. And then finally, be able to convert between Celsius and Kelvin. I didn't give you an example, but you can see it's a pretty straightforward formula. So we got through all my learning goals. I want you to make sure that you feel okay about these learning goals. So as you're going through and watching these lectures, and you feel like maybe we just covered a point here, then check off how you're feeling in these categories, right? When you first start, I don't expect that you're going to be ready to take the exam right away. You're probably all going to be in this category 3 when we start, and that's okay. That's why you're going to practice. Check out those question banks. Those are going to give you good opportunities for practice. And I'll speak more on those question banks during our discussion, okay? So that's a wrap for week 1, folks. We are 1/16 of the way there. Hallelujah. Okay. I will see you folks live on our discussions. Hasta luego.